Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on step-down chopper with RL and RLE type of load, resistive and inductive series connection of resistor and inductor, and next series connection of resistor, inductor and on battery. So now here step down chopper with RL load first I will explain. So step down chopper, in the first I am using here switch, and here I am using freewheeling diode. This is the RL load. So RL voltage, RL type of load voltage is V0. So that is plus and minus, and output voltage is the I0, and supply voltage is Vs plus and minus. This is the actual circuit diagram for step down chopper with RL type of load. This is load. Here you can take R load, RL load, RLC type of load. So now here, so when switch is on and when switch is off. So case 1 is for switch is on, and next case 2 for switch is off. So first I will mode 1. So case 1, switch is on. So here it is on, means it is short circuit. So in that case, so what will happen, the equivalent circuit diagram, when switch is on means this freewheeling diode will be in the reverse bias. So this is plus and minus, and it is short circuit, plus and minus occurs, and it is in reverse bias, that is diode acts as an open circuit. So now here in this chopper, it is RL type of load during this mode. So here I am using the gate IGBT switch. So in this case S equals, here I am using high signal S equals to 1. In this case the switch is on. So now here voltage across the switch occurs, the IGBT switch. So voltage across the switch is the ISW. So now here what is the output voltage? Output voltage equals to, so if you apply KVL in this loop, so Vs is equals to VSW plus V0. So now here the voltage across the output voltage V0 equals to Vs minus V0. So now here V0 equals to Vs plus V0. Vs equals to VSW plus this voltage, supply voltage equals to this voltage VSW plus V0. So now here V0 equals to Vs minus VSW. So this is the equation, that is output voltage. So now here in this case, so output voltage is okay, that is Vs minus Vw. What about the output current? So now here that output current, that means load current I0. So this I0 load current, so that is equals to, that is rises from I1 to I2. So now here that is rises. So here in this case the output current, that I0, so it starts from minimum value. So I1 means minimum value, and it is the I maximum value, rising current. So now during turn off step down chopper, so it will decay current. So I maximum to I minimum, that I will explain the next time when case 2 switch is off. So that is, so here current is flowing from rises from I minimum to I1 to I maximum I2. So now here second case, so when switch is off. So when switch is off means here in this case, switch is off means here in this case, in the previous case S equals to 1, that is high signal. So here signal is low signal, S equals to 0, that is given to the IGBT gate, to the IGBT gate signal. So now here this is IGBT gate, cathode, anode. So now here it is turn off. I am turning off the IGBT. I am turning off the IGBT switch using gate signal when I give this S equals to 0. So now here full load voltage is applied across. So this is open. So this switch voltage is directly applied across this one. And now here it is, this is open circuit, means here this V0 equals to Vs. So now here this voltage across the load is, So this load, this is output voltage V0 is 0. It acts as a short circuit. Output voltage is 0. So now here current, the load current I0 is decay from, so which will falls from I maximum to I minimum in the during turn on. So I1 to I2, and here from during turn off, after turn off, so here load current falls from I2 to I1. So means I1 is maximum, minimum, and it is a maximum, and again it come back to the minimum. So this is the case for RL for when switch is on and switch is off. So what about the waveforms? So here I am giving the output when switch is S equals to 1, and here S equals to 0, again S equals to 1. That gate signal, high signal I am giving, high signal to the IGBT. So this is the IGBT, and now here get this gate S equals to 1 I am giving here, and S equals to 0 when it is turned off. So now supply voltage is Vs, it is always constant. So during output voltage, this is the output voltage. Now what about the current? During turn on, it will starts from minimum value to the maximum value, I minimum, from the I1 to I2. So I maximum. Again during turn off, S equals to 0. So now here this S equals to 0 means here this output voltage is fixed, and now this is a 0. Output voltage is V0 is 0, and it decays, it falls from I maximum to the I minimum, means I2 to the I1. So now here step down chopper with RLE type of load. Step down chopper with RLE type of load means here same circuit, but here I am attaching one motor, means one battery. I am attaching RLE type of load. This is RLE type of load. Output current and output voltage, freewheeling diode current, chopper switch I am using. Here you can use any switch, IGBT, SCR, and now here input current and I0. So now here input voltage is always constant, and now here VA means output voltage, as we already seen in the previous lecture. So here this is output voltage, and this is when switch is off, switch is on, switch is off, and switch is on. Output current is constant. RLE type of load, output voltage is constant, and now here this I current, input current, and this is the freewheeling diode current. So now here during turn on only, so input current, during turn off, so freewheeling diode will comes into the picture. And now here, as we already know, output voltage, output voltage equals in the step down chopper duty cycle into V, output voltage VA, and now here duty cycle equals to T on by T. So this all we already discussed in the previous lecture. So now here if you apply KVL in this loop, so now here EB into IARE, EB is EB plus IARE plus I series R series, and now here into IA. So now this is the case for KE into omega n, and omega equals to omega m equals to alpha V minus IA RA plus IA I series by KE. So now here I am going to here in this case output current is starts from 0 to increasing during turn on, increasing from minimum to the maximum, and during turn off maximum to the minimum. And input voltage is, input current is linearly like this, and again during turn off this value is 0, and freewheeling diode current is previously also same, but here there is this voltage is EB. So here this is EB. So here this is during turn off only, diode current will flows. So now here, so now this is the case for freewheeling step down chopper with RLE type of load. So now here in this case, so now here it is operated in the first quadrant mode, VA and IA are in positive in the RLE type of load. EB is the back EMF of motor, DC motor, when the chopper is switched on. During turn on only I am explaining. During turn on period, T on, so the power is supplied to RLE. This power is supplied to RLE. During turn on, power is supplied to the RLE type of load. If you apply KVL in this loop, so what will happen? This diode is in open circuit, so it is in reverse bias. Diode, freewheeling diode acts as an open circuit. If you apply KVL in this loop, so here V plus EB plus IARA plus IA into RA, and next this L voltage across the inductor equals L di by dt. So this is the equation for when switch is on. So now here V equals L di by dt IARA plus EB. So now here it is only from 0 to T on. So during turn on period only. So now here what about when it is turn off? When it is turn off means, so here that supply voltage is 0. So now here it is turn off means here. So this is open circuit and freewheeling diode comes into the picture, and R, L, and this is EB. So now here in this case there is no, this voltage source is redundant, that voltage source value is 0. Here it is short circuit, this voltage value is 0. Same equation, minus I into R minus L into di by dt, and this is the EB. So this is the equation. Same equation, if you simplify this, L di by dt plus I into R plus EB is equals 0. So now this is the case during turn off. Turn off means from the turn on to the total time period. So now if you check this one, so now if you apply Laplace transform to the first equation. So if you apply Laplace transform to the first equation, Laplace transform to this equation, this Laplace transform to this equation, apply Laplace transform, and next apply Laplace transform to this equation. So now here if you simplify that, so R into I of S, so plus L into, this is L di by dt, so R into I, so plus L di by dt is equals to V minus EB. So that is the case. So now here in this case R into I plus L into di by dt is equals to minus EB. So this is the second case. This is when switch is on. This is for switch is off. So now if you apply Laplace transform to this equation, R into I. So I of t means here, so you will get the I of S, and L di by dt, derivative of Laplace transform equals to S into I of S minus I minimum. So I minimum means here initial value is during turn on. So it starts from I minimum to the I maximum value. So here initial value is the I minimum. So now here if you apply Laplace transform to the Laplace transform of di by dt means here, so S into I of S minus I naught. So I naught is the initial value. So this is not inductor. So that is Laplace transform of S. So now here this is the inductor. L di by dt, L di by dt, and L di by dt, and next L di of dt. So now second case, so why it is maximum? This is on condition I minimum to the I maximum. So this is the off condition from the I maximum to the during turn on. This is turn off. So I maximum to the I minimum. So in this particular case during turn off, it is the initial value is the I maximum. So now here I into R into I of S plus L into inductance S into I of S. This equation here it is a minimum, initial value is the I maximum. So see, this is carefully observed. So don't confuse here. So here during turn on, I maximum, I minimum is the initial value during turn in the turn off case. So in the case 2, So I maximum is a minimum value. So now here if you simplify these equations, so now here from these two equations, so here this is equation number 1 and this is equation number 2. In this case, so now here I of s equals to EB minus, so first case V minus EB into IS. So if you see this one, so R into I of S, from this separate this one, and S is already is fixed V minus EB by S. So now here IS means R plus S into LS, R plus LS, and next I minimum by R plus S. So we know very well. So now here in this case I minimum L into S, L into I minimum. So first I will write R into I of S plus L into S into I of S minus I minimum is equals to V minus EB by S. So here constant of Laplace transform is 1 by S. So this is 1 by S. So now here take I of S is common, I of S into R plus L into S minus L into I minimum. So now here, so this I of S equals to V minus EB by S minus L I minimum by I minimum only. So now here this R plus L into S. So now here LHS side multiplication of R plus L into S. So here RHS side denominator. So this is the final equation. I of S equals to V minus EB by S into R plus L in LS plus I minimum R plus S into L. So now here take L is common. Here take L is common. LL gets cancelled. So now here if you apply inverse Laplace transform to this one. Inverse Laplace to this one. So V minus EB by R is constant. Where is R? So here here in this case E minus VB by L. I think it is L. It is L. So now here 1 minus this inverse Laplace form is a E minus R by L into T. So now V minus EB by L. So now how it is R? So now I will explain first. So now here 1 by S into, take L is 1 by L, this one, plus 1 by S plus R by L. So now here this equation is, so 1 by L into S plus R by L minus, it is minus S by S into S plus R by L. So LL gets cancelled, this one gets cancelled, so only R you will get here. So now here if you separate this one, so here 1 minus E minus R by L. So actually it is written is 1 minus EB by L, 1 by S minus 1 by S minus R by L. You can write it as plus. So here this is 1 by S means it is 1 by S plus R by L is this is the inverse Laplace form of this one. So but here if you add these two terms, here you will get the R by L, L by R. So LL gets cancelled, only R you will get. So now here this one is the same as it is if you apply I minimum into E power minus R by L. So now here I dash equals to second case. This is for during off condition. So I dash equals to, so there is no V. So V equals 0 minus EB by R, 1 minus E minus R by L into T dash. So that is turn of time. I maximum, not I minimum. And now here minus R by L. So now here R is the armature resistance, and now here R series is the field resistance, series field resistance, L is the armature inductance, and L series is the series field resistance. So now here let me write I maximum and I minimum equals to I maximum from the values of I maximum, and next I minimum can be determined by I of t equals I minimum when t equals 0, I t dash equals I maximum when t dash equals 0. So now here from this, so the I maximum equals to, so V by R 1 minus E power R by L into alpha t by 1 minus E minus R by L into t minus E by R. And next second one is the I minimum equals to V by R e power minus alpha t R by L minus 1 by e power t R t by L minus 1. So here minus E by EB by R. So now these are the final equations for I maximum and I minimum. This I maximum is for during turn off period initial value, and I minimum is during turn on initial value. So now here what are the advantages of step down chopper? Step down chopper advantages means here it reduces the input voltage. Means step down means it will reduces the input voltage. If suppose V naught is less than the Vs, so that is the case. Lower level making it is suitable for low voltage is required. So now it operates at high frequency. So now it operates at high frequency means low switching losses as compared to the low frequency counterparts, so that the efficiency improves and power losses reduces. So here switching losses reduces means power losses reduces. Power losses reduces means efficiency will increases. And next it will provides the regulated output voltage even when the input voltage fluctuates. So if input voltage is fluctuates, so it will provide the constant output voltage. It maintains the constant power supply for sensitive electronic components. And next compact design, and it reduces the voltage. Next power dissipated as the heat also reduces as compared to the linear regulators. So now here what about the disadvantages? Here disadvantage of a step down chopper is, so it can introduce the output voltage ripple. So in the output voltage it reduces, but output voltage having ripple due to the switching nature of device. So it will introduce the output ripple, and this ripple can impact sensitive electronic components and may require additional filter circuit. So to remove that output ripples, so we need additional extra filter circuits are required. And next rapid switching of switching devices. Devices in the step down chopper can generate the electromagnetic interference. And next semiconductor devices such as power switches, IGBT, SCR, MOSFET may experience high voltage stress during operation. And now here what are the applications we know very well. So it is commonly used in the DC motor speed control application. And next here electric vehicles in the EV. Electric vehicles, they are used to control power supplied to various components inducing the traction motor. So now they are and also this step down choppers used in the telecommunication power supplies, and in the uninterrupted power supplies step down choppers also we will use. They are used to regulate the voltage and maintain the stable output during the power interruptions. And now they are used in the renewable energy systems, in the hydro power plants, in the wind power plants, to convert generating high voltage to low voltage and more usable voltage for grid integration. And next they can be used in the harvesting systems to efficiently convert and next manage energy from various sources to low power electronics devices. And next here one problem. So now here in this problem, first problem is, so a chopper circuit is chopping on TRC at time ratio control at frequency 2 hertz. And now here 440 volts, 460 volts supply, and that load voltage is 350. So this is a Vs is 460 and V0 is 350. So here it is step down chopper or step up chopper. So voltage is decreasing means it is step down chopper, that means buck converter. So calculate the conduction period of thyristor. So conduction period of thyristor means here we know very well V0 equals to alpha into Vs supply voltage, and alpha means T on by T into S V0. So now here conduction period means T on. So T on into T. Now here Vs, this is Vs is given 350. So time period means T means equals to 1 by F, that equals to 2 into 10 power minus 3. So now, so time period 1 by 2 into 10 power minus 3. So time ratio is 0.5. So this value equals to 0.5 milliseconds. So we know very well. So V output voltage equals to, this is delta into Vs. So now here delta equals to T on by T. So T is calculated here. So now here T on equals to, from this T on equals to, so V0 into T into T by Vs. So same way T into V0 by Vs. T value is calculated here, and V0 is 350 and Vs is 460. So now here, so conduction period of thyristor in each cycle is 0.38. So now here, what about the non-conduction period of thyristor means here, so T on plus T off equals to total time period T. So this is 0.5, this is 0.38. So this is T off means here this equals to T off equals to, so 0.12 is your non-conduction period of thyristor in each cycle. I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.